Hello everyone. This video is to discuss about the example of binary search and how to calculate the complexity through an example. Now let's see about it. So I'm taking a list of elements and this assume that this is an array of 0 1 2 3 4 5 6 7 8 9. So array of 10 elements, a of 10, and here a low value is 0, a high value is 9. So find out the middle element. Middle value is equal to low plus high by 2. So that is 0 plus 9 by 2, which is 4. Apply floor value for this. So you'll get 4, correct? Now I'm assuming some elements here: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. In the previous video itself, we discussed about this, that array what we are taking, that should be sorted fashion, non-decreasing order. Now, so here my key element also I have to tell, right? Key element, let us assume that I wanted to take as 35. Now your searching operation will go ahead that the first possibility is to check about whether the key element is a of mid or not. Okay, if the key element is a of mid, so a of mid already we found, which is 4. So key is what? 35. A of 4, a of 4 is what? 25. So 35 double equal to 25, it's not true. So 35 is what? Greater than from 25. So your target element 35 will be for sure at right hand side. That means your searching operation will be at this element to this element. So that's what we are dividing this whole list into 2, correct? From low to mid minus 1 is one set, a one sub problem. The other is what? Mid plus 1 to high. So if you keen observe these two, will be not going to search this and this, correct? Assume that list 1 and list 2, based upon the cases, either your element will be in list 1 or in the list 2, not in both the list, correct? Now we'll see an algorithm. So I'm taking recursive binary search. So A, L, H, comma, key element. If low double equal to H, that means my list is having only a single element. If list is only a single element, let's find out the list is itself a key element or not. If it is a key element, return that element. If that is not, return as 0, correct? Now else condition. So in the else condition, we'll be going to calculate middle element, low plus high by 2, and if key double equal to a of middle, then return mid. If key is lesser from a of mid, if it is lesser means array is sorted fashion, key is less than, that means key will be at left hand side. So we'll apply recursive approach where a comma low element will not go till high, will go to till mid minus 1, comma your key element, and else condition, return recursive binary approach, a comma mid plus 1 comma H comma key. So in this algorithm will helps you out to understand, will not call these two lists, will not call these two lists at a time. Either this will get called or this will get called. Let us suppose that the time complexity for this algorithm is T of n. So for each comparison operation, it will take 1 unit of time, and come to this, it will be take either this or this. So I'm assuming as T of n by 2. So the complexity of this T of n is equal to sum of these all complexities, correct? Now T of n is equal to 1 where n is equal to 1. T of n by 2 plus 1 where n greater than 1. So this is the time complexity of the recursive binary approach. That means T of n is equal to 1 into T of n by 2 plus 1. So when you look at this, we can solve this recurrence relation using 3 approaches. One is recursive tree approach, the other one is back substitution method, the other one is master theorem. So using master theorem, the complexity is what? Assume it is A and it is B. Okay. Now log 2 base 1 is equal to 0, that is n power 0. So now the time complexity using master theorem is what? Theta into 1 log n. So the total time complexity is theta log n. So you can watch master theorem video. So the reason why I wrote theta of log n, you can understand the better. Even we can do the same recurrence relation, finding the complexity using recursive tree and back substitution method. Let's see using back substitution method. So using back substitution method, the time complexity T of n is equal to T of n by 2 plus 1. Assume this is my first equation. So I know what is T of n. T of n is what? T of n by 2 plus 1. From this you can write T of n by 2. Substitute n by 2 in the place of n. That is T n by 2 by 2. That means 2 n by 2 n by 2 square plus 1. So this is what T of n by 2. We are substituting into T of n, right? Now we'll get 1 more plus 1. This is what T of n by 2. So finally T of n by 2 is equal to what? T of n by 2 square plus 1. Now substitute here. T of n is equal to T of n by n by 2 square plus 1. So this already plus 1 is there. Now T of n is equal to T of n by 2 square plus 2. Assume this is second. Now find out what is T of n square. T of n by 2 square. N by 2 square. That is, substitute n by 2 square where in the place of n by 2. That means n by 2 square by 2, it becomes 2 cube plus 1. So already plus 1, 1 more plus 1, it becomes plus 2. Now, 2 power 3, T of n by 2 cube plus already 2 is here. If I get this 1, it becomes 3. Now, so this is continued for k times. Finally, T of n is equal to T into n by 2 power k plus, I am taking this also k. So T of n by 2 power k will reach us to T power 1, the condition in the recurrence relation. So T of n by 2 power k is equal to T of 1. N by 2 power k is equal to 1, n is equal to 2 power k. If you apply logarithm on both sides, k is equal to log n. And t of n is equal to, what is the formula? T of k, we got this formula, right? What the formula is? T of n is equal to T of 1 plus k. So T of 1, why I have taken? Because it is T of n by k. This is the formula. T of n by 2 power k is what? T of n. So T of n is equal to T of n by 2k equal to T of n. So it becomes T of n is equal to T of 1 plus k. So T of 1 is what? 1 in the recurrence relation. What is k value? Log n. 1 plus log n. So that is T of n is equal to log n is the time complexity of binary search algorithm. You can call it is theta of log n, or you can call it is big O of log n. So the same thing you can understand with the any example of binary search. When you take the list of elements, if I am taking list of elements 0 to some 5, so all 0 to 5 elements I will not search. I have one possibility that in the first attempt my key element is equal to middle element. My key element is equal to the middle element. So in the first comparison I got successful search, correct? So the complexity, the best case complexity is what? Theta of 1. Finding the element in the best first comparison. And the second is what? Average case. Average is case what? If my element does not match with A of mid, that means the first case has been failed. It can be of x less than A of mid. It can be of x greater than A of mid. Any of the way, we will be going to find this. We will be going to complete the search operation in this list or in this list. That means the whole list is not going to be performed over here. Instead of n list, we will be dividing n by 2 list. That means n will get divided into 2 halves, n by 2 and n by 2. So if you apply logarithm on both sides also, you will get what? Log n. Log n is the time complexity, the average time complexity. Even for the case of worst time complexity also, it is log n. So finally, binary search best time complexity or best case is theta of 1. The worst case is theta of log n. The average case is what? Theta of log n. The recurrence relation is T of n is equal to 1 T of 1. T of 1 when n is 1. N is greater than 1. T of n by 2 plus 1. This is about binary search. Thank you all.